In this video, we're going to be continuing the RL from scratch in Python series, where we implement a reinforcement learning agent in Python. And in this video, we're actually going to be switching to gamengine3d, since Python was really slow, and also it's gamengine3d. It's just easier to have scripts, and you'll see what I mean once we get started. Okay, to get started, first of all, I'm going to show you what it looked like with Python before deleting it. So I'm in the same project here. I'm going to say python test.py, and you're going to see how slow it is. So you can see how slow the gravity is here, and you can just see like it's lagging a lot. Like even if I press spacebar, you can see how slow gravity is. You can see how slow I'm turning and stuff like that. So instead of that, we're going to use gamengine3d. Let's just clear this, and also I'm going to delete all of these files. Alright, so first what we're going to do is create a first we have to install gamengine3d. I already have it installed. You can say pip install gamengine3d, and that's all. I already have it installed. So you can see the latest version is 1.17.0. Now let's create a main.py file. So type null main.py, and just in here also, if you want to test your gamengine3d installation, you can type gamengine3d demo, and then you can just type the basics demo. So now this will open up just a small window with like a floor or something and whatever, and you can look at all the available demos using dash dash help. So demo dash dash help. So these are the available. So you have tons of these. You can look at the code, they have comments, so you can understand what they're doing. Now in our main.py file, we'll say from gamengine3d import star, which is import everything, and we'll say engine is, well, the engine. And then when you create an engine, it will create a window. So we'll say the width of the window is 1200 pixels, the height is 800 pixels. You can obviously change it for your screen size. The name, which is basically the title of the window, will say reinforcement learning from scratch in Python. And then let's say the background color will be, so we can just, there's a built-in color class, so we can say color.light blue. And then there's also an ambient light, so we can say ambient light equals, that is from 0 to 1, like it's a value from 0 to 1, so we can say 0.4, and we have to say ambient light. Then we can say I guess just engine.run. Now if we run this python main.py, you can see that, well, we have a 3D environment and the background is blue. It's like sky basic, it's light blue. Alright, now we also should create a scripts folder. So I'll say mk.scripts, so that we can attach all the scripts. It's more of a unity style package instead of Python, where we only have like one class or one file controlling everything. And then we also want to make a settings.py file, so we can change it easily. We can change the settings easily. And in settings.py, I will say from gamengine3d import, we'll just import the color and vector 3d, and we'll say the room. So we're going to create a room, like exactly what we did in the first 8 videos. We're going to create a, first we'll define the width, so we'll say room width, that will be 5, and then the block side length. So also have to define the grid rows. Now we're not actually going to be creating the well, like cosmetics in this video. It's just going to be the bare minimum. So there are 14 rows and grid columns will be so 6 columns. And then block side length will be the room width divided by grid columns. Then the length of the room, so room length, that will be the block side length times the number of grid rows. And then we can just define the room height, which will be just 4 units. And now we can package all of this into a room size, that will be vector 3d. The x is room length, y is room height, and z is room width. Right, now that we have that, we also have to go. So now we have defined our settings. For now, that's all the settings we need. And then we can go cd scripts, and then we can say we can create an engine init.py file. So let's go here, let's open that now. In engine init.py, again we're obviously going to say from gamengine3d import all. So here, you need to know how to spell import properly. And yeah, then we'll create a class engine init. Now if you want a if you want a basics or you want a tutorial video on how to use gamengine3d, I have a video on my channel of that. So basically this class here has to be the Pascal case version of your file name. Then we'll create the init method, and it will take an object which is of type engine, and it will take context which is of type context. Then we'll just say self.engine equals engine, or it'll be object actually. Self.object or self.context equals context. Then we'll create a light. So we'll say light equals a light object, or yeah, we'll create a light object. The position will be a vector 3d. In the x it is 0.01, and then we'll say the y value is self dot context dot. Okay, so for this we can go back to main, and we can say engine dot context dot runtime variables. So this basically it will be accessed by all of the, like it can be accessed by all of the scripts. So we'll say runtime variables dot from settings, and we'll provide the module name, which settings. If we were to say it's a file name, we would put a .py here, but since it's a module name, we don't add that dot here. Now runtime, so we'll say context dot runtime variables, that will be populated with all of these settings here. And then we'll say runtime variables dot, so the y will be the root height, and then the z value will just be 0, and then the color will be color dot white. The intensity of the light is 0.5. Again, it's a number from 0 to 1. And then we'll just say self dot context dot functions dot add light, and then we will add the light. Now we're actually going to be creating a floor. So we'll say the floor equals a cuboid. The position is a vector 3d. In the x-axis is 0. In the y-axis it is self dot context dot runtime variables dot floor thickness. So we have to define this now. So we'll say floor thickness, that will just be say 2. No, let's say it's 4 actually. Or yeah, no, 2 is fine. Now if we do this, at also have to divide by 2. This is because when you say an object is at a certain position in the gamengine3d, the middle of the object goes to that position, and then the corners or whatever are calculated from that position. So it's not like the top left corner or something like that. So if we want the top edge of the floor, to be at 0 0 or 0 in the y-axis, then that means the middle should be half of the width down, which is what we're doing here. And the z is 0. Now we'll say the size is a vector 3d. So the size is, so in x-axis itself dot context dot runtime variables, not root length. This is why we defined it in here instead of just passing our own parameters right here. That's because if we want to change something, then we can't change it everywhere. You'll see we're using these room length, height, and width a lot, so we can't just change them in all the places. That's why we made a variable and settings. So dy will be self dot context or runtime variables dot floor thickness, and the z will be self dot context dot runtime variables dot room width. The color will be self dot context dot floor or runtime variables dot floor color. We have to define this again. And lastly, the name of this object will be floor. Now let's go to settings. Let's say floor color is a color class. Now if you want to specify your own color, not just a built-in one, you have to say color dot, here you can just say color like this and pass it in, or you can say color dot rgb and pass it in. So we'll say color dot rgb. The floor color will say R is 88, G is also 88, and B is 93. And also we have to say self dot context dot say functions dot add object, and we will add the floor. Now if we run this, or no, before running this we actually have to attach the script. So in main.py we'll say engine dot attach, and we will attach script slash engine init.py. Now if I run this, I'll cd back out. Now if I run this, I'll say python main.py. Oh yeah, also, yeah. So there's a you have to have mandatory, or yeah, it's a mandatory function or method in this case, which would be update, and it will take it in dt and we'll just pass. Now if we run this, it should work. Yeah, you can see we have a floor here, and yeah, right. So now let's go back to settings and define a few more things. We'll say the wall color will be color dot rgb, and it is just all white actually, so we don't even need this. So color dot white. And we'll also, let's just define the background color here. So we'll say background color equals color dot light blue, and we'll change that here. So we'll say from settings import background color, and instead of color dot light blue we'll just say background color here. Now we'll that should be all, I guess. And then in the engine.py we'll just create the rest of the walls. So we'll say the back wall will be a cuboid position. I'm just gonna paste it here. So we just have the back wall. The back wall is this, the position is this, and then the size is this, and then the color is the wall color, and then the name is back wall, and then you have the same thing for this. It's basically the same thing we did in the first iteration. And of course we have to add all of those. So we'll say We'll just do this so that we're adding all the walls. Now if I run this, we should have all the walls there. Now what I can also do is I can just create a scene. So what I'll do here is in my other project where I have the actual code, I can even say engine dot save scene, and I can save it into something like rl.json. And now if I run this, so it has saved it into rl.json. I can copy this file, I can paste it here. Now we have rl.json. I've saved the scene. I can just say gamengine3d load rl.json, and then dynamic view, we want that to be true. So now I will get all of this, but except it won't have all the scripts obviously because I don't have those scripts here, but the rest exists. So I have basically everything here, but I could do that, but we're going to write the code from scratch. Now that we have the walls and stuff, what we can do is we can also create the countdown. So as you saw, we had a countdown in the back. So we did some modification, we did some optimizations for that to work, and there was like a update loop or whatever. Here we don't even have to do much. Here we can just say countdown will be a text object, and also in settings we will define timeout time, so that will be 15 seconds, and timeout equals false at the beginning. And in engine.py we can just create a text object, and the size will be, so it's a text object, and the text will be the number, if not 15, it will be a string of self.context.runtime variables dot countdown or time, like this. And then the rotation, it will be a vector 3d. So if you were to just do it like this, it would be facing up, but since we want to rotate it, we want to rotate it 90 degrees on the x-axis, and y will be 0 and z will automatically be 0. The spacing between the digits or the characters will be zero point 0.7 units. The position will be vector 3d, x is 0, y self.context.runtime variables dot room height by 2, so it's in the middle. And then z will be just it will be negative self.context.runtime variables dot room width by 2, and we also want to add, so we have to say by 2 first, and we also want to add 0.01 just so that it comes out a bit instead of sticking to the wall. The name is countdown text, or we can actually just say countdown. What is the problem? Yeah, okay, I forgot a comma. And the color will be color dot black. The scale of the text will be vector 3d, so now we can stretch it in all three directions, but I'm just going to double it in all directions, so it'll be 2, and then center equals, so basically it will just be in the center. Then we'll say self.context.functions add object, we will add the count. Now if I go ahead and run this, it appeared here. So yeah, you can see if we zoom out here, we have the countdown, and I'm also going to do this. Alright, so now let's also just position the camera properly so we don't have to keep zooming out. So what I found was we can go to here, And after saying after importing the settings, we can say, or actually before doing that, engine.camera.move to, we will pass a vector 3D. I found that x could be 0, y is 1.5, and z is 4. So that might look good. Yeah, you can see it's a lot. I guess, yeah, it's proper, I guess. Yeah. Now let's make the countdown actually count. So here we don't have to keep writing stuff for the countdown. What we can do is, actually I'm going to create a new terminal here. I'm going to say cd scripts. In scripts we can say type null countdown.py, and we'll open that from gamengine3d import all, and then we'll say class countdown. Then we'll define the init. Just the same thing basically. Object will be of type text, context will be of type context, and self dot object equals object, self dot context equals context. Then we'll make the update method, which will take dt, and the update method for now let's just pass. And what we can do is we'll create a new method here called self it's a method, it's called decrement. And again, you need to know how to spell decrement. This, and it won't take any parameters. So the value, the current value or the time or whatever will be self dot object dot text, and then we'll just say self dot object dot text equals a string of int of value -1. That will just convert, since the text is a string, it will convert that to an integer. It will subtract one and convert that back into a string. And now you're probably wondering, how do we call this? We still have to do that timing thing with the if time is greater than 1 second, or if the last update was greater than 1 second and stuff. We don't need to do all that. We can just say self.context.add scheduled caller, and we can just say it is the end times is self.context.runtime variables dot timeout time, and we need to add 1 so that goes and updates again on 0, and then the delay is 1 second. Callback is self dot decrement. So what this will do is it will literally just keep calling this function or method, in this case, this many times with a delay of this. That's all that does. And then now in engine.init we can actually say countdown.attach. We will attach scripts. We'll attach scripts slash countdown.py, and it will also take engine.context like this. Now if I run this, we get an error here. Oh yeah, so it's not engine.context, it would be self.engine.context. Now you can see the countdown is counting. That's all we have to do. Instead of doing those optimizations and whatever, it's just going to count, and it'll get to 0, and it'll just stop at 0. Obviously we want to restart when it gets to 0, but you can see when it gets to 0, it goes to -1, because again, when it's on 0 we call it again, so it updates, and that's all, it stops there. And that's how easy it was. And then we can say in countdown.py, we can say if self.object.text, or actually we can say if value is 0, so if it's the last one, we'll say self.context.runtime variables dot timeout equals true, and we'll say return, and we'll say if value is 1 otherwise. So if it's 1, we want to make the next value red, right? So we'll say self.object.color, it'll be color.red like this. Basically, when it hits 1, it'll be called again, and then it will, before updating it, because when you update it, it goes to 0. So before updating it, we change the color to red, and if it is already 0, we just say runtime was the timeout equals true, and then we return before again decrementing it, which would go to -1. Now in the update loop, we can say if self.context.runtime variables.timeout. So if we have timed out, we can say self.object.color will be color.black, and we'll say self.object.text will be a string of self.context.runtime variables dot timeout time. So basically how much time it takes to timeout, and then self.context.runtime variables dot timeout will be false, so it's not timed out anymore because we have just reset it, and we'll just call this again so that we again have a caller here. So I just keeps decrementing again. So now if I run this, you can see it will go to 0, it'll become red, and then after a second it'll just restart and go back to 15. You can see it went to 0 and now it's back to 15. And yeah, so now let's create the player. So we'll say go to scripts, or no, first we'll create an engine init.py, and in settings also, first of all, we have to define something. In settings we'll say this should actually be before, so it should be like here. In settings we'll say the agent speed, it is 4 units per second. Agent rotation speed is 100. Agent size is a vector 3d of the block side length, and we want it a bit smaller. Actually, we don't even have to say block side length 3 times. We can just pass in one value, it'll set all of the components to that value, and we want it a bit smaller than that, so we'll say times 0.6, so it's 60% of that. Next, the agent jump force will be vector 3d dot up, so it's going up, right? So we'll do vector 3 dot up, and we'll multiply that by 7, so 7, well, the force is 7. Alright, so now let's go back to engine it. Here, after the countdown, we can say the player, or inside we'll say the agent actually equals cuboid. The size will be it'll be self dot context dot runtime variables dot agent size. So I guess we define that, and then the color will be color dot light red. The name is obviously agent. Position is vector 3d. X is 0. Y is the agent size. So I'll show you agent self.context.runtime variables dot agent size dot y. So in the y axis by 2. Again, that's because the middle of the agent will go to this. That means the bottom edge is touching the top edge of the floor. And then the z is 0. Then we'll just say self dot context dot functions dot add object. We will add the agent. So now let's try this, and you can see we have an agent here. So now let's add some controls and gravity and stuff like that. So to do that we'll go back here. We'll say type null. We'll create a agent controller.py, and then let's open that, and again just the same thing. We'll say from gamengine 3d import everything, and we'll say class agent controller, create the init method, it'll take a cuboid. The context is of type context. Self dot object equals object. Self dot context equals context. And then let's create the update method. It'll take dt and pass for now. Now let's create a move method. So therefore we could say, yeah, we could say move. It'll take dt, which is delta time. Obviously you want that for if you want per second stuff. And we also take direction. We'll say if first of all, let's also import one more thing here. We'll just do pass for now. We'll say from gamengine3d dot helper, we'll import get forward. This will just get the forward vector from our rotation vector, basically, kind of like that. Then we'll say forward equals get forward. It will be self okay, self dot object dot rotation, and yeah, we'll say if the direction we want to go is equal to forward, then we'll say self dot object dot position plus equals a vector yeah self dot context dot runtime variables dot player speed times dt and times the forward vector, so we go forward instead of some random direction, instead of diagonally. If you say a vector 3D plus a scalar, it adds that scalar to all of the components. So we would be going kind of diagonally if we didn't have the forward. Now we'll say LFD direction is equal to backwards. Then we'll say self dot object dot position minus equals the same thing. Then we'll say the if direction LF direction is a left, we'll say object dot rotation or self dot object dot rotation dot z minus equals self dot context. So basically it is the agent or not player in this case, it's the agent speed, right? Yeah, it's the agent speed. So it'll be the agent rotation speed times dt, and we're not going to multiply by forward obviously, because why would you, it's your turning it, so you don't need to multiply by forward. Otherwise, if direction equal right, self dot object dot rotation dot z plus equals the same thing. Now this will just, I mean, if we call this function then it will move, but we need a way to have like a key callback. So if we press a key, it will call this function with the correct direction and also provide dt. So we can do that here by saying in the init function self dot context dot on held, we'll say w is held, we'll say self dot move, the callback is self dot move, so it will call this function when w is held, and the arguments will be forward like this, and the next is dt, so we can say that is true, it'll pass dt. If we say it's true, it'll pass dt, otherwise it won't pass dt. Then we can just copy this 4 times. Say if we press S, we want to go backwards, and then otherwise we want to go left, right, and those will be if we press A and B. So now if we run this, we should have some player movements here. So we can do this, and I'm not, oh yeah, obviously we have to actually attach this. So we'll say agent dot attach script slash agent controller dot py, and we'll also pass engine dot context like this. So now let's run this. Yeah, again it is self dot. Yeah, so now if we run this, I can I can turn, but if I turn, everything turns for some reason. And I guess there's a quick, but if I go forward and backward, that's working. So I guess there might be some bugs, so we can just fix that by saying self.object.rotation will be vector 3d dot 0. So basically we're saying the rotation is 0, and what's important here is we're creating a new vector, because I'm pretty sure in the actual code it might be using the same vector instance, which means if we change one we change the other, but here we're detaching it, so we're creating a new vector 3d. That's that. So now if I run this, we should have some movement here. So I'll actually just full screen this. Yeah, I'll zoom out and you can see that, well, we have some movement, but yeah, we have some movement actually. I can go forward, backwards, I can turn right, I can turn left. Now for some gravity, because we can't implement jumping without gravity, of course. So let's again go back to settings. In here we'll just define gravity, so we'll say gravity equals vector 3d dot down, since gravity is down obviously, and we'll multiply that by 15, so the acceleration would be 15 units per second. And yeah, that's that. Let's go back to agent controller and we'll create a new method called def gravity. Actually, before gravity we want it so that we don't bang into the walls, right? So to make it sure we don't bang into the walls, we can we'll just create a new method here called, so we'll say def resolve collisions. So if we collide or anything, it will just push us back, so we're not colliding. Then we'll say, we'll actually create another function also. We'll say sign. So the function name is sign. It'll take in x, and it's basically really simple. We'll return 1, or we have to say return 1, negative 1 if x is less than 0, else we return 1. So basically it's telling us the sign of x, which, yeah, which sign it is. So we'll say half of the boundary size. Boundary is the room size, right? So half of that will be self.context.runtime variables.room size by 2, right? Since it's half the room size. And if you think about it, we want it so that there's a tolerance, because if we just resolve a collision here, and if we say if the agent's position is going there, we want to stop it if it's about to go outside. That's the middle of the agent, but if we want like the edge of the agent, that means we have to actually have some tolerance so that the edges are a bit closer or a bit inward, so it's a smaller box, right? So we can subtract the tolerance here like this. That way we create a smaller boundary. So if the middle of the agent goes, if it's about to go past that boundary and we stop it, that means the edge of the agent is about to go past the actual room walls, and we stop it then. And then we'll say if the absolute value of the position in the x direction is greater than half the boundary size, again in the x direction. Basically, if we went past the threshold for boundary, we'll say the position dot x will be half the boundary size in the x direction times the sign of the x. Basically what this means is if we're about to go past the boundary in a certain direction, whichever direction that is, either the negative or positive side, then that's why we're taking the absolute value, so we don't need two if statements. So then if we're going past it, then we'll come back and we'll say x equals the threshold instead of going past it. And since there's two, positive and negative, we'll take the sign of x, which will give you negative 1 or positive 1, and that will basically tell you which side of the boundary you're on. And same thing for y. So if the absolute value of the y is greater than half the boundary size dot y, or not y, actually it's z, y will be handled by gravity. And then we'll say position dot z will be half boundary size dot z times the position dot or sign of the position dot z. All right, so now in the move function, after moving, we don't really want to keep calling it in the update, because if in the last frame we haven't moved, and we have moved since the last frame and the last frame was proper, then we don't want to keep checking this. It's just inefficient, right? So only after we actually move, which is when a key is pressed and we move, then we'll say self dot resolve collisions. The position is self dot object dot position. The tolerance will be self dot context dot runtime variables dot the agent size, and we can just pick any direction. We'll pick the x direction, or we don't even have to pick a direction, because there is a vector minus vector which will just subtract the corresponding components. So now if we do this, now let's see here. So we can be able to, we can move still, and yeah, you can see we can't go past the boundary here. And for some reason there's a gap. Oh yeah, obviously we can't say the size, we have to say by 2, otherwise it'll be too big, because it's the center, so it means half of it. That's why it was too big. So now if I were to go back, yeah, you can see that if I'm facing directly towards the wall and I push forward, I don't go anywhere. But if I'm facing a bit to the left, I push forward, I don't go forward, but instead I go left, because I'm colliding with the wall in the forward direction, so I can only go left because there's nothing there. Alright, and now also it can't fall off the edge because we still have that boundary. It's an invisible boundary, as you will say. And also there are shadows here. There are built-in shadows with gamengine3d. You can see, I mean, before we implement jumping, we can see that we have shadows here. And yeah, we have to implement jumping for it for you to be able to see it clearly. So now let's implement gravity. So we'll say def handle gravity. We'll just create a new method. It will take in dt. Now, if we are not colliding with the floor, then we want to apply gravity. Otherwise, obviously, you don't want to keep going to the floor. So we'll say if not self dot context dot functions is colliding. So this is basically going to check whether two game objects are touching, which means they're colliding. So the object name, which is in this case player, but we can just say object name, which is the same thing. And if we're colliding with the floor, that's why we have to specify a name here while creating it. So you saw here the name was floor, so we can actually check whether they're colliding. So if they are not colliding, we'll say, so we also will say the velocity, which is self dot velocity. That will also be vector 3d dot 0. And down here we'll say yes, the self dot velocity plus equals the gravity. So self dot context dot runtime variables dot gravity, and we'll multiply that by dt. So it's kind of like now this is going to give us the speed, right? Yeah. So since it's acceleration, the integral of acceleration is the speed. The second integral would be position. So now we got this. So this is the speed, which is this velocity. Velocity is just speed in direction, right? So now we have that, and then we'll just say self dot object dot position plus equals the. So if we just say plus equals velocity, we're adding the speed, which doesn't make sense. So we also have to multiply that again by dt, which is kind of like integrating the acceleration twice. That will give us the new position, right? So if we add this, it gives a new position. So we'll say the velocity times dt. Now we can say if we are colliding, the velocity will be just vector 3d dot 0. So we reset the velocity, and self dot object dot position dot y will just be self dot object dot size dot y by 2. So if we are colliding with the floor, we want the bottom edge of the agent to be on the top edge of the floor, which is why we have this. Alright, so now in the update loop, or in the update method, we'll just say self dot handle gravity and we'll pass dt. That's all we have to do, and this should do the exact same thing. So we should still be able to move and do all that fun stuff. But to check if gravity is working, over here we can say uh, the position of the agent in the y direction. We can just add 2 units to that, so it'll just be hovering. It won't be exactly on the ground, and you can see it has fallen. Now we just have to implement jumping now, right? That's all we have to do. So I'll actually just delete this. Yeah. So now in settings, we have already defined agent jump force. So basically, the force when it jumps, we already defined that here. And then we'll go back to agent controller, and we'll close all of these. So we'll just do this, and then in move, we'll say if the direction is up, which means we're going to jump. If it is up, we will just say, so we only want to jump when we are touching the floor, right? So we'll say if self dot context dot functions dot is colliding. So self dot object dot name, and it is floor. So if we are touching the floor, then we want to say self dot object dot position plus equals vector 3d dot up. So basically we're just going to push it a bit up, and just a small bit. So we'll say 0.001, like this. We'll just push it up, that way it's not touching the floor, and on the next frame or next update call, handle gravity will see it's not touching the floor, and it'll apply velocity. But we're also going to say it's the velocity plus equals self dot context dot runtime variables dot, okay, not this, runtime variables dot agent jump force. So basically we'll just say the object's position is a bit higher than it is right now, and we'll say the velocity is positive. That means, so in gravity it'll see the object is not touching the floor, so it'll just apply a small change to the velocity. It'll just decrease it a bit, but since the jump force is greater than the velocity in like 1 instance or whatever, that will mean that we have so it'll apply the velocity, and then the velocity is still positive, it's not negative, right? Because it was a very high value, which is I guess 7 in this 7 units, and we multiply 15 times, like, 15 times 1 over 16. That's a small value. We subtract those two, so velocity is still high, and then we say object the position of the object plus equals velocity times dt. In turn it'll just jump up, basically. That's all it will do. And also we have to obviously say if we press the space bar, then it will go up. So now we should be able to run this, and you can see when I press space, we jump, and you can see the shadows clearly now, right? Yeah, you can see the shadow on the floor, and yeah, you can see that. And that's it for this video. And if you want to see how to use gamengine3d, I have a video on that, and also you can see it on my website. I'll put a link in the description about gamengine3d. There's more documentation there. And that's it for this video. Okay, bye.